And then our last presenter is Sybil Wong with Sparrho. Sybil?
I'm here to tell you a little bit more about our experience as a startup that serves solely scientific researchers. So we're a discovery engine for scientific literature alone, including mathematics and engineering. So for us, we are facing users who already need to get in touch with all of this data. They need to be on top of it. And for them, what the crisis is not the fact that there's more data. More data is great. We want more literature, more information. But the question is how, in a limited amount of time, can we make sure that we scan through all the stuff that is relevant and sift out all the stuff that isn't relevant? So for us, it's really an irrelevance crisis. We're streaming so much into our feeds every day. How do we know what to give to our users first rather than later? So just a little sense of what this problem is. As Bab has already mentioned, you have 2.5 million articles being published a year on average. So you're looking at 208,000 articles every month. And this is across science, but as a scientist, I'm agnostic, right? I might be in biology, but potentially something in engineering should be within my field. Even something in mathematics might be within my field. I can't rule out that these 208,000 articles are relevant to me. However, if you look at the latest survey, the median number of articles that a researcher actually reads from top to tail is only 22. And they spend around 30 minutes reading each of these. And since the survey was started in 1977, this is the first year in 2015 that that number has plateaued. So it seems to me that our researchers are reaching a real peak of what they're able to digest every month. 22 articles is not a small number. And this is 22 articles after they have decided of all these 208,000 which to read. So in this case, as a researcher say, I'm looking at only being able to parse one article per 10,000 that comes out every day. So that's quite a scary thing. If we want to put it into a graphical sense, this star field is what I'm looking at in terms of trying to read in the coming month. Potentially, I may find an article in that little patch, but where do you even begin if you're faced with that star field? So that has been the question that we've been trying to tackle at Sparrho. It's not just recommendation, but recommendation in a timely manner. So one of the really important things when we're talking about recommendation is how do you understand what the users are using your tool for? You can recommend them all sorts of things. And say in the field of publishing where books may be out of interest or for other reasons, there's a broader range of motivations for why people want to keep up. For researchers, because we've refined our user base, it's relatively easier. So when we look at our users, there's 2 reasons why they use us rather than Google search. This is a question I get all the time. So why use us instead of Google search? So the fact is that they're not sure what they're looking for, but they do need to know what's going on. So the first thing that they want to get is inspiration for new ideas. I'm a researcher. I need to be on top of what's happening and also trying to get inspiration every day for what else I should be asking. Can't just go down a rabbit hole. And 2 very serious problem is staying ahead of the competition. If I'm working on something, I want to make sure that nobody else is working on it. Or if somebody is working on it, we should be collaborating rather than trying to outcompete each other. So those are the 2 things that we really tried to work out. But understanding the motivations is really important, as I try to explain here, is that you can't just work out what people want from what they do. So say I run Amazon and our customer Sam has just bought black socks. My question is, what should I recommend to him next, given that he's just bought black socks? Without any other further information, I could choose to give him more black socks. Maybe he wants blue socks, or maybe he wants shoes to go with his socks. Without understanding why Sam is buying socks, I can't recommend him the right thing. In the same case, for us, if our users are looking for inspiration, then I need to give them a range of less stringent matches. So I don't want to give them just stuff that matches their keywords or their certain journals of interest. Whereas if they're trying to stay ahead of competitors, for those ones, it's almost easier for the machine to help because they know exactly what they're looking for. In a sense, they know the range of keywords and the range of authors they should be aware of. So one way that we approach the way to give people enough information or enough of a selection to choose from to read is a reductive approach. So the machine is quite good at looking for exact matches and ruling out things that certainly aren't right. So for us, we're tackling it in a way where, okay, so if it wasn't published in the last 30 days, don't show it to them. If it's not even closely related in terms of a discipline, don't show it to them. If they're not related to articles that, or if it's not citing articles that match somewhat the keywords of interest. This is all fuzzy, by the way, so it's not as simple as this. But this is one way to approach it. So rather than thinking about trying to find the needle in a haystack, you're actually trying to split up the haystack into smaller and smaller haystacks until the person can just kind of wave through it and find a needle. So that's what we're asking our machines to do. So rather than trying to look for that point straight away, we give them, okay, actually, you just need to look through that part of the sky, and given your expertise, you probably will find the thing that you need. And so this is what we're trying to do. So going back to what Babis said and also what Jim has been saying, you know, we feel that machine curation or the fact that we use machines to recommend things is not a way to replace humans. Machines are very good at doing certain things. They're very good at looking through a huge amount of data and telling you exactly what's happening, given the criteria you've given it. And they're also good at finding unexpected results. A lot of the scientific literature is dominated by databases that are used by a lot of researchers. So if I go to PubMed, there's actually a 2-year waiting time for a new journal to get onto PubMed. So if I'm trying to look for new things and it's not on PubMed and I don't actually have any other way of doing it, then that's a problem for me. So what we're trying to do at Sparrho is to make sure that regardless of the esteem of the journal, that we make sure that they're streaming into our platform so that as long as the content is relevant, our users are seeing it, and our machines can pick out that. So they don't bias, so I don't just go to Nature or I just go to Science to look for my news, go to Sparrho and I can see a cross-section of everything that's coming out. Humans, on the other hand, and this is where natural language processing really will start to help humans, is to recognize alternative phrases that describe their keywords of interest. So as a machine at the moment, if you're looking for neurochemistry, it may be able to pick up neuroscience, but potentially brain chemistry isn't going to be picked up. And we need humans to help with training those algorithms to make sure that we can pick those up in the future, and we need to collect that data. Also for us, humans are good at recognizing stuff that's relevant to them. There's no difficult maths involved. They just look at something they know. So we want to make sure that people are doing this, because every time they do that and every time we record that reaction, we get that data, and that's one more thing to help us build our algorithms. So one of the ways that this has really been happening, I think one of the leaders in our field for curation and for recommendation is Spotify. They released something called Discover Weekly in 2005, last summer. And what they did was they realized, wait, we actually have all the data we need to make great recommendations. We have 2 billion user-created playlists. Each of these users has decided that these songs sound right together. It doesn't matter what the songs are. It would be nice to know what the songs are about and therefore make further predictions about if something new comes out, whether they would like to put it in their playlist. But in terms of understanding existing preferences, those playlists are the best things that could happen to us. So for them, they just looked at, okay, well, if they're in a playlist, then something very simple called collaborative filtering. So say if I have user A and B, user A and B share 9 tracks that are exactly the same. But user B has 3 more tracks. So chances are, if I recommend those 3 tracks to user A, they'll probably find it interesting. So that's one way they've been refining their algorithms. And it is something to look at and think about when you're building recommendation platforms, aside from just understanding the content, which I think is really, really important. But also understanding how your users are reacting to that recommendation. So for us, this is very bright. So what we've done in our new version is to allow pinning. So the previous version has just been personalized feeds. So literature comes through your channel, and if you like it, you click relevant. If you don't like it, you click irrelevant. But there's no way to store it, and there's no way to create a collection of what is most important to you. So we've made sure in our next version, in the new version that's actually up now, that we have pin boards where people can, one, save the things that they want to read later, share with people later, as well as discuss. So we've added comments. We currently don't have the processing power to understand what these comments mean. We could work with Jim, say, to try and understand what's happening. But this is all trying to create the right data for us to understand what the sentiments are and why people are looking at these particular articles as a cohort and as a relevant collection. So that is now being fed into all of our algorithms to make sure that when we do make recommendations, they are more relevant and are based on other recommendations that have been made by users in places that you might not even know of. So this is one way that we're trying to make sure our algorithms are more accurate. So my prediction is, I think if you're not doing it already, you should be really looking at how are we looking at users collecting things. So imagine, say, for Amazon, if they could understand every customer, what they already have on their bookshelf, and then base recommendations on that rather than just their sales history, that would be a much more powerful thing. And it may be a social way of trying to find that out. But if I'm building a platform where people are already constantly using it, then I want to make sure that I'm collecting all that data so that in a year's time, I can have a much better search algorithm than everybody else. So that's really it from me.
Well, thank you. Thank you, Sybil Wong with Sparrho.